Beneath the glittering surface of the ocean lies another world, silent, endless, and crushing. A world where sunlight fades into blackness and pressure builds strong enough to collapse steel. Down here, in the cold and the dark, life doesn't just survive. It transforms creatures that should be small, have grown to impossible sizes. Imagine a shrimp the size of your forearm, a jellyfish stretching wider than a house, or a squid lurking somewhere in the abyss that could easily match the length of a school bus. This phenomenon has been given a name, Deep Sea Gigantism. Scientists have been studying it for years, but no one fully understands why creatures of the deep are so massive. Is it the freezing temperatures that slow down time? Is it the crushing pressure that forces life to adapt in ways we don't yet comprehend? Despite years of research, we still don't know for sure. Is it the cold, the pressure, the darkness, or something deeper? Something written into the very fabric of how life adapts when pushed to its limits? Today, we're diving into one of the ocean's greatest mysteries, not just to meet these giants, but to uncover what forces are sculpting them into the titans of the abyss. Let's start with what we do know. Deep sea gigantism isn't a myth. It's a well-documented phenomenon, observed across various species below 1,000 meters. Take the giant Isopod, for example. If you've ever seen a pill bug, the small, ball-shaped creature that rolls up when disturbed, now imagine that same critter, but the size of a small puppy. That's Bathynomus giganteus, one of the largest crustaceans on Earth. It can grow to 50 centimeters in length and weigh over a kilogram. This scavenger of the abyssal plains feeds on the scraps that drift down from above, armored with a hard exoskeleton to survive in this harsh environment. It thrives on whatever marine snow floats down from above, including bits of dead fish and plankton remnants. Then there's the Japanese spider crab, with legs that can span nearly 4 meters from claw to claw. Moving slowly, deliberately, this giant seems like something from another age. While its body may be small compared to its limbs, its reach is unmatched among arthropods. In the open waters of the deep, the colossal squid reigns. So elusive that we've only seen a handful of specimens, it's believed to be the largest invertebrate alive, with eyes the size of basketballs, the biggest eyes in the animal kingdom. Those enormous eyes aren't just for show. In the perpetual dark of the midnight zone, bigger eyes mean better vision, making the difference between catching prey and going hungry. Amphipods, those tiny shrimp-like creatures often found in tidal pools, also undergo this transformation. In shallow waters, they're only a few millimeters long, but in the Mariana Trench, they grow over 30 centimeters, nearly the length of a ruler, swarming in packs and scavenging anything that falls to the ocean floor. Even jellyfish follow this pattern. The Tiburonia grandis, a giant red jellyfish, drifts through the depths with a bell more than a meter wide. Unlike most jellies, it has no tentacles, only thick, fleshy arms that it uses to capture prey. This massive jellyfish, slow and ghostly, is a giant among jellies in the deep. The deep star jellyfish is another rare species found thousands of meters below the surface. With its thin, translucent bell, it moves in ghost-like ripples, lacking traditional tentacles. When illuminated, it can appear to glow softly, adding to its eerie, otherworldly appearance. And then there are the tubeworms at hydrothermal vents, like Riftia. These worms can grow over 2 meters long, thriving in superheated water filled with toxic chemicals. Without mouths or stomachs, they survive by farming bacteria inside their bodies, a strategy that makes them giants, not by hunting, but by nurturing life. So, Why do these creatures grow so large? The answer starts with physics. In the deep sea, temperatures hover just above freezing, rarely rising past 4 degrees Celsius. Cold water slows metabolism. Chemical reactions in the body, like those powering growth and movement, happen more slowly in cold temperatures. This would be a disadvantage for most animals. But in the deep sea, where food is scarce and energy must be conserved, a slower metabolism becomes an asset. When your body burns energy slowly, you can survive for longer periods without food. You don't need to hunt as often. And in the abyss, waiting is often the best strategy for survival. There's also oxygen. Cold water holds more dissolved oxygen than warmer waters. This is crucial because larger bodies need more oxygen to function. In tropical seas, growing too large becomes a problem. Your cells can't absorb enough oxygen fast enough. But in the cold depths, oxygen is abundant, enabling larger creatures to thrive. And then there's pressure. At 4 kilometers down, the ocean exerts a force of over 400 atmospheres. That's like having a dozen elephants standing on every square inch of your body. For us, this would be fatal. But for deep sea creatures, pressure is just another part of their environment. Interestingly, pressure might actually favor larger body sizes. Smaller animals have a higher surface area to volume ratio, meaning pressure affects their cells more intensely per unit of mass. Larger animals, with more volume relative to their surface, may handle pressure more efficiently. Their cells are less affected, and their internal structures remain stable. Larger animals are also better at surviving. The giant Isopod, armored and as large as a football, is a difficult target for predators. Its exoskeleton is thick and dense. Very few predators have jaws strong enough to break through it. Size here becomes armor, a shield from harm. Many deep-sea giants reproduce slowly, producing fewer offspring but investing more energy into each one. The giant grenadier fish, for instance, lays fewer eggs than its shallow water cousins, but each egg is larger, giving the hatchlings a better chance of survival. This is a strategy known as K-selection, favoring quality over quantity. The deep sea, in many ways, is a refuge, a place where evolution can move at its own pace, unhindered by the pressures of the surface world. This is a stable environment that has changed very little over millions of years, allowing species to evolve slowly, refining their adaptations over eons. For centuries, sailors have told stories of monsters rising from the depths, kraken and massive sea serpents capable of dragging entire ships under. These weren't just myths. They were attempts to explain the unexplainable. We now know that many of these legends came from real encounters, giant squid washing ashore or being caught in nets. Their massive bodies and enormous eyes would have seemed monstrous. But the reality of deep sea gigantism is far more fascinating. These creatures aren't monsters. They are survivors. The deep sea is the largest habitat on Earth, covering more than half of the planet's surface. And yet, we've explored less of it than the surface of Mars. What other giants are waiting down there? What other adaptations, what survival strategies are out there yet to be discovered? The deep sea doesn't give up its secrets easily, but each answer we find reshapes what we thought was possible. If you want to learn more about these incredible creatures and the mysterious zones we've mentioned today, check out our previous video on the deep sea. Each dive into these abyssal depths brings more questions than answers. But the journey is one we can't stop exploring